Hello everyone, and welcome to this video tutorial on the H2MA tool. Today, we're going to explore the tool and see how it works. We will go through the whole process step by step to visualize each content and discover all the features that tool delivers. So let's dive in. The H2MA tool provides a numerical interface for visualizing and computing data related to the hydrogen infrastructure for mobility applications in the alpine space. The tool bases its calculations on a database information that has been collected by the project partners and their partner regions and around. It develops three main functions: visualize the available information of existing and planned hydrogen refueling stations and green hydrogen production sites, compute cost-optimal configurations for scenarios defined by the user, and visualize and save the obtained configurations through the calculations. Now, it is time to initiate the walkthrough and understand how the H2MA tool works. The first thing you need to do is to extract the files from the zip folder. Once you've done it, you can launch the tool by double-clicking on the file, h2mapp.exe, and wait for the initial window to appear. You can now click on the New button and select the area of analysis you desire from the drop-down menu. I will now select the Lombardy region. Then click on Start and wait for the input data to load. Once the loading is complete, you will enter into the main interface of the tool, where the navigation occurs through different tabs. These tabs are Current Situation, Scenario Definition, Data, and Scenario Optimization. We will now go through all of them one by one. We are now displaying the Current Situation tab, which contains three main windows: Alpine Space Map, Hydrogen Refueling Stations, and Hydrogen Production Sites. The tab we are looking at now is the Alpine Space Map. It visualizes the existing and planned hydrogen infrastructure of the entire alpine space. All of them are indicated through different symbols, which are explained in the legend on the top right. The infrastructures displayed here showcase the existing hydrogen refueling stations, colored in blue, the planned hydrogen refueling stations, colored in yellow, the existing hydrogen production plant, colored in purple, the planned hydrogen production plant, colored in red, and the Trans-European Transport Network, showed with a red line. On the map, you can click on each point to see its characteristics and zoom in using the lens. To go back and zoom out, simply use the Home button. You can also click on the Pan button to activate or deactivate the Pan function. Following the next tab, we can see the Hydrogen Refueling Stations tab, which shows a list of the existing and planned HRSs with their main features. This table does not have any special features. It just serves as a database for the map of the alpine space of the previous section, and it just gives another perspective on the data collected. Finally, in the last tab are displayed the hydrogen production sites, containing a list of existing and planned hydrogen production sites with their main characteristics. Similar to the table before, this table also does not have any special features. We will now pass to the next window, the scenario definition. Once we open it, we can see that it is divided into three main areas: hydrogen in mobility, vehicle stock, and average hydrogen daily demand. Starting from the hydrogen in the mobility area, you first need to enter the desired value of FCV by vehicle category. It includes cars, trucks, buses, and trains. I will now assign a value to each category. It's important to remember that the tool accepts values between 0 and 1, and at least one of the values must be higher than 0. Otherwise, there is no hydrogen demand, and the tool cannot compute any cost-optimal configuration. Keep in mind that we are envisioning the future share of H2 vehicles in the investigated territory, which is up to your own projections. Here on the following tab, you can see the FCV-specific consumption values, divided by vehicle category. These values are provided by default, but it is possible to edit them if needed. Going to the next step, you can select the hydrogen production and import features. Under the hydrogen production section, you can select the option or options that you desire. Remember that if on-site production at HRSs is selected, you also need to edit the PPA electricity price for its supply. In the hydrogen import points section instead, if you want to consider one or many import points, you need to fill in the table with latitude, longitude, capacity, and hydrogen price. You can easily copy-paste the latitude and longitude out of Google Maps. Finally, you need to select the hydrogen delivery modality from the drop-down menu. You can choose between hydrogen pipelines or compressed hydrogen trucks. Remember that this selection is required regardless of the included hydrogen production options, but it won't affect any of your before preferred and selected options, especially if you have chosen the on-site production of H2. The point is that the tool won't work without the selected H2 delivery modality. We are now ready to see the next table, the vehicle stock. Here you can visualize and, if needed, edit the tables on overall vehicle stock. The values displayed are provided by default from the input data database. The default values were provided by partners and are very close to the real situation of the regions. Now that all is ready, you can finally click on Confirm Scenario. Once you do it, the map on your right will update, showing the results regarding the calculation made on the data provided. The map gives information about the average hydrogen daily demand, from the lowest, areas colored with light green, to the highest, areas colored with dark green. Let's now check the Data tab. This tab simply serves to visualize and edit techno-economic data, which are organized in sub-tabs. The values here are provided by default, but they can be modified if desired. We can now follow with the last tab, the Scenario Optimization. Here you first need to click on the Initialize Scenario button to initialize the scenario for the optimization. A progress bar will pop up, and after its competition, a map is displayed, showing the candidate network for hydrogen delivery, which depends on the selection of the modality you have chosen before, meaning that it might showcase the pipeline network or the H2 compressed trucks delivery routes. You can now click on Start Optimization button to start the optimization. This step will take some minutes, as stated by the message box that will appear while the optimization progresses. It is preferable to not interfere with the operation. We advise you to not click on the application while loading, since you might disturb the process and the optimization might crash. After the process is completed, results are visualized on the map located in the right part of the window. Here, if you click on a point on the map, the related information appears. The legend on the top right explains what each point addresses. There are 3 subtabs of results. The first is showing installed HRS, the second displays the hydrogen production points, and the third gives information regarding hydrogen delivery. The last tab finally shows a summary of all the scenarios. Keep in mind that different scenarios can be run sequentially, and every time the input assumptions are varied, the scenario must be confirmed and initialized through the Initialize Scenario button in the Scenario Optimization tab. If you intend to analyze a different region instead, you need to close the app, open it again, and select the desired area. As you can see in each tab, the Save button is available. When you save a result, the following formats can be used: Installed hydrogen refueling stations, shapefile format; Hydrogen production quantity by sub-area, spreadsheet format; Installed hydrogen production sites, shapefile format; Hydrogen delivery network, shapefile format; Summary table, spreadsheet format. Remember that the shapefiles can be used in any GS tool as input files. This is all for now. I hope this tutorial has been useful and clear. If you want to discover more about the H2MA project, do not forget to check our webpage and follow us on Facebook and LinkedIn. Have a wonderful day.